Imagine waking up every morning wearing a 20-kilogram weighted vest, your neck locked in a brace, your eyes smeared with Vaseline. Every step sends a dull ache through your joints. Every breath feels like effort. That is not a thought experiment. That is the daily reality of over 800 million people right now. That is what aging actually feels like from the inside. 150,000 people die every single day from diseases directly caused by aging. Not from cancer alone, not from heart disease alone, from aging. The single underlying process that makes cancer more likely, makes heart disease more deadly, makes Alzheimer's inevitable. Aging is not a side effect of these diseases. Aging is the engine driving all of them. For 30 years, a team at Harvard Medical School has been asking one question. Why does this happen? And can it be stopped? In this video, you will get their answer. You will understand exactly why your cells age, what is destroying your DNA right now without you feeling a thing, and how intermittent fasting intervenes at the molecular level to slow and reverse that damage. The researcher behind this work is Professor David Sinclair, a geneticist at Harvard Medical School. His findings are the foundation of everything you are about to hear. Inside every one of the 37 trillion cells in your body, there is a strand of DNA roughly 2 meters long, compressed into a space smaller than the period at the end of this sentence. That strand contains approximately 20,000 genes. But having the genes is not the same as using them correctly. Think of your DNA as a vinyl record. Every song ever written for your body is pressed into that record. Instructions for healthy skin, a sharp mind, a heart that beats without error, an immune system that hunts cancer cells before they become tumors. The information is all there. But what determines which songs play and which stay silent is a separate system sitting on top of the DNA. Scientists call it the epigenome. The epigenome works through chemical tags, methyl groups attached to specific points along the DNA strand, that tell each gene whether to switch on or stay off. Think of them as sticky notes across the record. Play this track, mute that gene. When you are young, these sticky notes are placed with perfect precision. Every cell knows exactly what it is. Then the scratches begin. Every time your DNA suffers damage from radiation, chronic stress, or the basic process of cell division, the proteins responsible for maintaining those epigenetic tags abandon their positions to perform emergency repairs. These proteins are called sirtuins. There are 7 of them. They are the most important biological system you have almost certainly never heard of. Sirtuins have 2 competing jobs. Job 1, sit on the epigenome like conductors in an orchestra, ensuring every gene plays its correct part. Job 2, respond to DNA damage by leaving their positions to coordinate emergency repair. Every time a sirtuin leaves its post, it does not always return to exactly where it started. Some drift, some land on the wrong positions. The epigenetic tags they maintained get smudged or lost entirely. Over decades of this process repeating across trillions of cells, the conductors abandon the orchestra. Cells begin to forget what they are. The precise system of youth degrades into biological noise. The scientific term for this is epigenetic drift. The everyday term is aging. This is the information theory of aging, Sinclair's central framework. Its profound implication? If aging is the loss of epigenetic information, not the loss of DNA itself, the information might still be recoverable. The record is not destroyed, it is scratched, and scratches can be repaired. The evidence is striking. Identical twin studies in Denmark show that 2 people with the exact same DNA can age at dramatically different rates based entirely on lifestyle. One twin smokes, stays sedentary, eats constantly, and by 60 looks 20 years older than the twin who exercises, fasts, and eats selectively. The DNA did not change. The epigenome did. Your genes are not your biological destiny. Your epigenome is. Sirtuins do not operate for free. They require a fuel molecule called NAD+, nicotinamide adenine dinucleotide. When you are 20, NAD+ is at peak levels. Your sirtuins are fully fueled, maintaining the epigenome and repairing DNA simultaneously. By 50, peer-reviewed research confirms your NAD+ has dropped by approximately 50%. Your sirtuins are running on half a tank. DNA damage stacks up faster than it is repaired, and you feel nothing until a disease appears that your doctor treats as if it came from nowhere. Here is what accelerates that decline. Every time you eat, your body releases insulin. Insulin activates mTOR. Activated mTOR suppresses AMPK, the precise enzyme responsible for producing new NAD+ through a protein called NAMPT. When AMPK is suppressed, NAD+ production slows. When NAD+ drops, sirtuins lose fuel and abandon the epigenome. 3 meals a day means 3 insulin spikes. AMPK suppressed for most of your waking hours. NAD+ crawling. Sirtuins running on fumes. Every additional source of DNA damage compounds this. Smoking, which breaks DNA strands directly. Frequent flying, which exposes you to elevated cosmic radiation. CT scans and X-rays. Ultra-processed food, which drives chronic inflammation and floods cells with free radicals. Alcohol, even 1 drink per day, which a UK biobank study found was associated with measurably smaller brain volume. Loud concerts, where extreme acoustic stress accelerates aging in inner ear cells. Every one of these forces your sirtuins off their posts more often.
Every departure leaves the epigenome a little more degraded. This is the abundance trap. Modern life has engineered constant feeding, constant stimulation, and constant DNA stress. Your biology was optimized for a world of scarcity and physical effort. It is paying the price. First, breakfast is not the most important meal of the day. That claim was established by the breakfast cereal industry in the early 20th century, not by science. Sinclair himself skips breakfast consistently. The human body was never designed for food at regular intervals from the moment of waking. Here's what actually happens when you extend the gap. In the first 4 to 8 hours after your last meal, insulin is elevated, AMPK is suppressed, and NAD+ production is slow. Your body burns through glycogen, the emergency glucose stored in your liver, roughly 100 grams, lasting 8 to 12 hours at rest. Between hours 8 and 12, glycogen empties. Most people reach for a snack here. That is not starvation. That is metabolic transition. Your body switching from externally supplied glucose to internally stored fat. The discomfort fades after 1 to 2 weeks of practice. Between hours 12 and 14, the switch flips. Insulin has been low long enough that AMPK reactivates. It signals NAMPT to increase NAD+ production. NAD+ climbs. Sirtuins receive fuel. They return to their positions on the epigenome. The conductors take their seats. Between hours 14 and 16, autophagy begins. Your cells consuming their own damaged components, misfolded proteins, broken organelles, molecular debris that has built up since your body last had a long enough break to deal with it. Think of autophagy as the cleaning crew that can only enter after the office closes. 14 to 16 hours opens the door. Yoshinori Osumi received the 2016 Nobel Prize in Physiology or Medicine specifically for his work on autophagy mechanisms. Beyond 24 hours, chaperone-mediated autophagy, CMA, increases substantially. Unlike standard autophagy, CMA specifically targets the protein aggregates directly implicated in Alzheimer's disease and Parkinson's disease. Research from Ana Maria Cuervo's laboratory at the Albert Einstein College of Medicine confirmed that CMA activity declines with age, and that this decline closely correlates with the emergence of these diseases. A monthly 72-hour fast activates this system at a level no overnight fast can reach. And separately, A CDC-funded study found that people who exercised 30 minutes a day, 5 days a week, had telomeres, the protective end caps of chromosomes, that measured biologically 10 years younger than sedentary individuals. Both fasting and exercise activate overlapping AMPK pathways that protect the epigenome and telomere integrity at the same time. In 2020, Sinclair's team published a landmark paper in Nature demonstrating that 3 specific genes, OCT4, SOX2, and KLF4, referred to as OSK, when introduced into aged cells, actively reset the epigenome toward a younger state. The epigenetic age of treated cells decreased by approximately 75%. The cells did not revert to stem cells. They did not lose their identity. They simply became younger versions of what they already were. The scratches on the record were erased. The music returned. In animal models, old mice equivalent to 85-year-old humans showed significant extension of remaining lifespan. Blind mice recovered measurable vision within weeks. The same approach showed positive results in models of brain aging, hearing loss, multiple sclerosis, and motor neuron disease. The work has been replicated in primates. The delivery mechanism for human trials uses a modified virus, an AAV2, stripped of disease-causing capacity and repurposed as a delivery vehicle. The OSK genes are packaged inside, injected into the target tissue, dormant until the patient takes doxycycline, which activates the genes for 6 to 8 weeks. The eye was chosen first because it is an enclosed, controllable system. The conditions being targeted, glaucoma and retinal arterial occlusion, causing sudden blindness in approximately 30,000 Americans per year, with no current treatment. The disease connection is direct. When mice engineered with human Alzheimer's genes developed dementia, reversing the epigenetic age of their brains caused the symptoms to disappear. The researchers did not treat the disease. They treated the aging. The young brain healed itself. Aging is not merely a risk factor for Alzheimer's and cancer. It is the foundational driver. Treat aging, and the diseases it produces begin to resolve. The gene therapies are in trials, but they are not available today. What is available today is the biological framework those therapies are built on, and a specific set of behaviors that activate the same molecular systems. The underlying principle is hormesis. Controlled adversity activates the body's repair systems. Adversity tells your biology to take maintenance seriously. Modern life has engineered almost pure abundance. Your AMPK never gets switched on. Your sirtuins never get their fuel. The goal is to reintroduce the right adversity in the right places. Fasting. Stop eating after 7 or 8 p.m. Delay your first meal to 10 a.m., then noon as your body adapts over 2 weeks. You are asleep for 8 of those fasting hours. In exchange, AMPK reactivates, NAD+ recovers, sirtuins refuel, autophagy begins, every night. Once a month, healthy adults without metabolic conditions can extend to 72 hours to activate chaperone-mediated autophagy at the level that clears the protein aggregates overnight fasting cannot reach. What you eat. Ultra-processed food eaten to break a fast collapses the NAD+ recovery the fast just produced. Break your fast with whole food rich in polyphenols, molecular compounds produced by stressed plants that activate the same adversity response pathways as fasting, including direct sirtuin stimulation. Blueberries contain anthocyanidins with documented sirtuin-activating properties. Extra virgin olive oil contains hydroxytyrosol and oleocanthal with strong anti-inflammatory effects. Shade-grown matcha contains EGCG at up to 10 times the concentration of standard green tea. Brussels sprouts contain sulforaphane, which activates the NRF2 cellular defense pathway. Limit alcohol. Limit ultra-processed food. These are molecular instructions, not generic wellness advice. Movement.
Exercise activates AMPK through an independent pathway, the energy demand signal from working muscle. Get out of breath for at least 5 minutes 3 times per week. Add resistance training to maintain muscle mass and support testosterone naturally. Heat and cold. Regular sauna use is associated with significantly reduced cardiovascular mortality in large Finnish population studies. The mechanism involves heat shock proteins induced by thermal stress. Cold exposure activates complementary adversity pathways. Both work on the principle of pulsing, deliberate stress followed by recovery, not constant exposure. Sinclair's projection is not cautious. Medicines capable of resetting the biological age of human tissue will reach the market within the coming decade. The generation currently in their 20s and 30s, if they maintain their biological systems until those medicines arrive, will have a meaningful chance of living into the 22nd century. AI is accelerating the timeline. Sinclair's laboratory has screened approximately 8 billion molecular candidates to identify compounds that could replicate the OSK gene effect in a simple pill. The mice come first. If they get younger and live longer, the implications for human medicine follow directly. 80 to 90% of your rate of aging is not determined by the genes you inherited. It is determined by the choices you make about when you eat, what you eat, how you move, and how much adversity you allow your body to experience. The epigenome is not a fixed document. It is a living system responding to every signal you send it every single day. You are not a passive passenger in your own aging process. You are the driver. The window is every hour you go without eating. The window is every meal you fill with color instead of processed carbohydrates. The window is every time you choose to get out of breath instead of staying still. These are molecular events happening inside your cells, real, measurable, and cumulative, moving your body toward one that ages more slowly, repairs more effectively, and remembers exactly what it was built to do. Comment below, how many hours passed between your last meal yesterday and your first meal today? That is your current fasting window. And now you know exactly what it is doing, or not doing, inside your cells. If this changed how you think about aging, hit the like button, subscribe, and turn on notifications.